Dear listeners, welcome to our presentation. My name is Tomáš Lieskovan, and today I will present our article on the topic of building a cyber range to teach cybersecurity. Let's talk about what this presentation will deal with. First, we will go through the introduction, what is cyber range, why we need cyber range, state of the art, type of training and scenarios, and the comparison of available open source cyber range platforms. Subsequently, I will present our contribution, how we build the cyber range at BUT, performance results and other planned activities which are now possible thanks to the deployed cyber range at BUT. Cyber attacks has been gaining in frequency and in size recently. Hackers' targets have changed. Their goals are no longer distribution centers and company servers. Government organizations, hospitals, and critical infrastructure are increasingly being attacked. With this increasing number of cyber attacks, an increasing number of security experts are needed. This is connected with teaching and simulation of attacks, for which, thanks to the features offered by CyberRange, CyberRange is becoming the perfect tool for simulating cyber attacks and teaching cybersecurity. What is CyberRange? NIST defines CyberRange as cyberranges are interactive simulated representations of organizations' local network system, tools, and applications that are connected to a simulated internet-level environment. Thus, this does not specify how the cyberrange is internet resolved, whether hardware or based or software based, but generally defines its function. In general, the more separate the cyberrange environment from the operating system is, the more operations it offers. Choosing the right platform is very important. Currently, it is possible to choose from many platforms, but many of them have not been developed for a very long time, or no scenarios are available for this platform. Support is available for commercial product, but for open source community is needed. The community size is therefore also a very important factor. Choosing the right platform is therefore very important. CyberRange can be divided into many ways. In our opinion, the main divisions are according to use and game style. If we are talking about division according to use, then these are the tests and teaching purposes. In the case of test ones, the cyberrange is isolated and its environment it is close as possible to the real one. In the case of educational purposes, this environment does not have to be strictly separated in this way. It is not even possible sometimes, and it is possible to interconnect multiple players in the same time. Division according to the player game style is based on the difference whether the player plays alone or plays as a team player. If he plays alone, the game is called Capture the Flag, where the player's task is to search for flags. In the case of correctly entered flag, the game continues, otherwise players can use hints. Team play is based on the cooperation of two or more teams. Two players, blue and red, are commonly used with one team, most often red, representing the attackers, and the team blue representing the defenders. The red team is trying to take control of the blue team's infrastructure, and the blue team is trying to protect its infrastructure in real time. Here you can see a table comparing the most famous open source cyberrange platforms. The table shows both the last source code update and the number of scenarios available. From our point of view, the only possible platforms are those that are currently updated, which are the last three in the table. We get to our contribution. Building a cyberbranch is not an easy task. While building cyberbranch, we found that there are no cyberbranch comparisons that are suitable for teaching. At the same time, there are no instructions guides to guide the user from the start to finish. A cyberbranch is a very complicated platform and requires knowledge from many fields. Currently, a completely open source solution and its stress testing are missing. The article aims to answer all these problems and provide a step-by-step guide so that every reader can build a cyberbranch exactly as we did. The manual also includes a list of required hardware, including installed operating systems. Another benefit is stress testing and experience with using cyberbranch for teaching. So this is what our rack looks like, where all the equipment needed to run our cyberbranch is located. The controller server is a supermicro server with 6-core processor and 32 gigabytes of RAM. We call this server as a controller, and all the services needed to control a compute server run here. The compute server is a Dell Proliant with two 48-core processor cores and 512 gigs of RAM. All virtual machines run here. The Kaipo portal runs on separate server as a virtual machine. However, it will be transferred to controller or compute server in the future. We also use Synology backup server for backupping, and we have connected the whole laboratory with 10 gigabit per second Ethernet. All devices are backed up in case of power failure. From a network perspective, as I mentioned, all devices are connected by 10 gigabits Ethernet. For the OpenStack and Kaipo services to work properly, it was necessary to create two separate networks, which are called the management and provider networks. Management network is used to manage devices and to ensure OpenStack communication. As provider network is needed for traffic that is intended for virtual machines. Using this network, virtual machines can communicate to the internet. To eliminate mistakes on our part when creating our own scenario, we use the official demo scenario. This demo scenario demonstrates all the features of Kaipo, allowing us to test all features to see if they work properly. The demo scenario consists of several tasks where the student has to perform a network scan, scanning for computers on the network, find open ports, running services, and exploit vulnerabilities. After successful exploiting, the student needs to find a way to escalate permissions and infiltrate the root user's home directory. On the compute server, performance was measured using the OpenSSL tool. Virtual machines always had one processor assigned to them. Our measurements show that CPU usage has always been equal to the number of running OpenSSL processes. In terms of performance, we did not use our full capacity. From the point of view of RAM of the computing server, we also did not use the full capacity, but this was caused due to good optimization of virtual machines. This capacity was also not fully used, but it was found that it is not possible to create more virtual machines than the capacity of the main storage. Although all our virtual machines took up 50 gigabytes of space, but 1 terabyte of space was reserved. However, this situation is different for the controller. At the time of creating virtual machines, the entire controller sometimes froze because of high load. Kaipo controls the OpenStack through the control API, which, when busy, reacts with a delay, which is reflected in the creation of flags. while playing the game, or worse, by disconnecting the players from the game. When we were designing the entire solution, it was not considered that the high performance of the controller would be needed, so a 6-core processor was used. In the future, this server will be replaced by a more powerful one. Our other activities will be focused on automatization and industrial networks. Nowadays, the number of attacks on this type of network is constantly increasing, so we want to focus on simulating attacks on these networks. We have laboratories for smart grid networks, industrial networks, and automatization. We will connect these laboratories to the newly created cyber range, and we will virtualize devices and internal networks, where we will simulate attacks and countermeasures. So as a conclusion, I would like to say that we summarized available open source cyber ranges. We have built fully functional cyber range laboratory. We have created a guide to deploy cyber range laboratory as we did. We performed performance test and tested our cyber range with real students. Thank you for your attention.